This question is taken from the ENGAA 2020 section 1 paper, and it is question 21. So we read, a block of mass m slides down a rough slope. Initial velocity equals v1 at position 1. Final velocity equals v2 at vertical distance h below position 1. So this is a setup right here. What is the work done against friction from position 1 to 2? So the immediate thought when doing work done can normally be force times distance. But the expressions in the answers that we have seem to do it in terms of energy. So the method that we should use is energy. And by this we mean the initial energy and the final energy we can calculate, and then we can see what the difference is between them. So the initial energy is mgh, the gravitational potential energy, plus half mv1 squared. That's the initial kinetic energy. Then when it reaches position 2, the final energy is a half mv2 squared. So if there was no work done against friction, then these should be equal. But if there is some work done against friction, then the discrepancy or the difference between them will be that work done. So if we take the initial, take away the final, we have the work done against friction must be mgh plus half m v1 squared minus v2 squared. And as I said before, it would be 0 if there was no work done against friction, so the energies should be the same. But if there is, then this will be the work done. The answers don't seem to give anything in this form, but we have to make a manipulation with this. So if you just switch the order of v2 and v1, like the answer suggests, then put a minus sign out here, we have the answer is B, mgh minus a half m v2 squared minus v1 squared. So this part you just had to rearrange in order to get it in the form the answers wanted.